This video is about solving systems of inequalities by graphing. To do this, we just have to graph each of these inequalities together on the same grid and highlight our solution set. So y greater than negative 2x plus 4, we graph the line y equals negative 2x plus 4, which has a y-intercept of 4, a slope of negative 2, which is like negative 2 over 1. So we go down 2 to the right 1, down 2 to the right 1, and we can continue this. Now this is just greater than, so instead of drawing a solid line, I would have a dotted line through here, which it'll look better on the next screen. It's very hard for me to get this drawn correctly. But it is greater than, and we talked about this in another video. Greater than just means to shade above. So that's that line. The other line is less than or equal to x minus 2, a y-intercept of negative 2. There is a coefficient of 1 here, so it's a slope of 1, up 1 over 1, up 1 over 1, etc. It is less than or equal to, so it will be a solid line. It is less than, so we shade underneath. And here's it looking a little bit neater. There was our first one, here's our second one. This whole region in here is our solution set, where we have it double colored. So all of the points in this region will be our solution set. Now notice this is a dotted line. That's the only way I can show you dotted on this grid like this. So any point in this region is a point that will work in my two inequalities. So pick a point over here like 1, 2, 3, like right here, 4, 0. If you put a 4 in for x and a 0 in for y, it checks. Negative 2 times 4 is negative 8, plus 4 is negative 4. 0 is greater than negative 4. Put your 4 here, your 0 here. 4 minus 2 is 2. 0 is less than or equal to 2, so we have shaded the correct region. Y less than or equal to negative 1/2 x plus 3, a y-intercept of 3, a slope of negative 1/2, down 1 to the right 2, down 1 to the right 2. It is less than or equal to, so I am going to have a solid line, which goes about here. It is less than or equal to, so it's going to be everything underneath here. To do the next line, it has a y-intercept of negative 1, a slope of 3, which is up 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, and let's draw the line here, which looks about like this. And it is greater than, so we are going to shade above. So here's the graph a little bit more neatly drawn. This is the region where we are double colored. So this right here would be the highlighted solution set. All the points in this region will make both inequalities true. You can check it on your own. Pick some point that's in this region, plug it into both inequalities, and you'll find you have a true statement. This next system is not in slope-intercept form, so we have to take a few minutes to get both of these rewritten for y. So in this one, I subtracted 3x from both sides, which left me with negative 2y less than or equal to negative 3x plus 4. I divided everything by negative 2. Remember, when you divide an inequality by a negative, you must switch the inequality sign around. So that less than turns into a greater than. That's going to be one of my inequalities to graph. The other one, subtract x from both sides, and then divide everything by 3. Remember, there's like a little 1 here, and that's how we get this inequality. So here's the two inequalities written up neatly, and let's graph them. The first one has a y-intercept of negative 2, a slope of 3/2, which is up 1, 2, 3 to the right 2, 1, 2, 3 to the right 2. Draw the line, and it looks about like this. It is greater than or equal to, so it is a solid line, and we are going to shade above. So that's all of that one. The other line has a y-intercept of positive 2, a slope of negative 1/3, down 1 to the right 3, down 1 to the right 3. It is a dotted line, so my line is going to look kind of like this. This looks kind of sloppy, but it'll look nicer on the next screen. It is less than, so it's all of this. So this is what it looks like a little more neatly. There's the dotted line for the second one, solid line for the first one, and where the region overlaps, the red and the blue, is all of this. If you pick a point out of that region and plug it back into these, but better to plug it back into the originals, you'll find that we have shaded the correct region. Here's another one like that. Let's rewrite this for y. Subtract 3x from both sides. We have negative 3x plus 6. It is less than, but we are dividing by a negative, so we've got to flop that sign around, giving us that inequality. This one was easy to solve for y. Just subtract 4x from both sides, and there you go. There's the two inequalities, and we're going to have a y-intercept of -3, a slope of 3/2, which is up 3 over 2. Let's draw the line, which looks about like this. It is greater than or equal to, so it is a solid line, shade above. The other one has a y-intercept of -1, a slope of -4, which is down 1, 2, 3, 4 to the right 1. Let's draw the line. A little bit steeper this way. It is less than or equal to, and it is going to be a solid line. And that missed a little bit. It'll be cleaned up on the next screen. We are less than, so we'll shade underneath. So here's what that looks like. This is where the region overlaps. So all of this is my solution set. That is the solution to both of those inequalities. Pick any point in that region and you'll find out that it works. There are a couple of special cases, and hopefully you recognize looking at these two inequalities that they have the same slope but different y-intercepts. That means that these lines are parallel. But there's two things that can happen with the shading of these parallel lines. So let's graph this and see what happens. A y-intercept of -4, a slope of 2, which is up 2 over 1, up 2 over 1. Let's graph the line. It is less than or equal to, so I get to draw the shaded line. It is less than this way. The next one has a y-intercept of +1, has a slope of 2, up 2 over 1, up 2 over 1. And let's graph the line. This one looks like this. It is greater than or equal to, so it is solid. And it is greater than, so it shades above. So here it is a little more neatly drawn. And you notice that there is no overlap region. That means that this system of inequalities has no solution. What we're looking for is where it is double colored. It is not double colored anywhere. That means there is no point that will work in both of these inequalities. I have just made a minor adjustment on the last two inequalities. I've just flipped these signs around to show you something different. So this is going to be the same idea. We're going to have to graph the line y equals 2x minus 4. We have a y-intercept of -4, so start there. Our slope of 2 is up 2 over 1, up 2 over 1, etc. So I can draw my line from there, which looks about like this. It is a solid line because it is greater than or equal to. Because it is greater than, we will shade above. So it would be all of this. The other one says y less than or equal to 2x plus 1. So for that one, I have a y-intercept of 1, a slope of 2, up 2 over 1, up 2 over 1. Draw the line. It is solid because it is less than or equal to. And this one is going to be shaded underneath. So this is what it looks like a little more neatly drawn with our overlapping region. Remember, when we are solving these systems of inequalities, we are looking for where it is double colored. So our solution set is all of these points between the parallel lines. So if you picked any point within this region, like here, let's say, and put it into both this equation and this equation, that was the point 1, 1, and check, you get a true statement. 2 times 1 is 2, minus 4 is -2. Is 1 greater than or equal to -2? Yes. And on this one, 2 times 1 is 2, plus 1 is 3. Is 1 less than or equal to 3? Yes.